When tasked with approximating the area under the curve with a midpoint Riemann sum, we usually find ourselves given more data values. And often is the case, in fact almost always, if not always, we're going to be charged with 4 equal subintervals. Not always the 4, but the equal. The subintervals are going to be of equal length. This makes it easier for us to identify where the midpoint of each of the regions, of each of the subintervals, is going to be. All right? So we know that we have to go from 1 all the way to 9. All right? So our A, if you will, we're going from 1 to 9 of h of x dx. All right? And we're approximating this. 1 to 9, so 9 minus 1, that's a total of 8. And we have to break it up into 4 subintervals, which means each subinterval needs to be 2 units long. So we're going to go from 1 to 3, right? 3 to 5, 5 to 7, and 7 to 9. Right? And every single subinterval is going to be 2 units long. There's the bases of each of our rectangles. And this time we have a left value, a right value, and then a middle value. Since we're doing a midpoint Riemann sum, we want the middle values. So we're going to do 2 times 6, 2 times 5, 2 times 9, and 2 times 9 again. So 2 times 6, that's our first subinterval. 2 times 5 is our second. 2 times 9 is our third. That's this 9 right here. And then 2 times 9 is our fourth. That's that 9 right there. And again, we're multiplying our y values times the change in x. Right? So we're looking at 12 plus 10 plus 18 plus 18. And we can do some mental math there and get an approximation of 58.